Yeah. So good evening, everyone. Good evening. So in the yesterday's class, we done the lecture number 1. Now lecture number 2. So today date is I think 19. Let me write 19/11/25. Today's date. Just I started now. Let me know audio video okay or not. In the yesterday's class, we completed approximately 8 problems. Today we are going to cover approximately, I can say 10 to 15 problems I will try. Right? If you are comfortable today's class and yesterday's class, you will be definitely fine with the time complexity finding. Right? The purpose of these lectures are you should be clear with the time complexity finding so that we can go to the remaining topics further. Right? So let's start. Yesterday we done the 8 problems. Today we are going to do, I think, approximately 10 to 15 questions. Right? Let's start. So in my opinion, today's class is just starting now. 19/11/25. Today's class is just starting now. So 9th problem. Start. So what is the time complexity of this program? One program is given. What is the time complexity of this program? So please, first of all, whatever language I am doing, please do it. Right? In Python language, just syntax will change. Learn the syntax. Or Java language. C++, Java, C++, Java almost similar. Similar will be there, but in Python, slightly little different will be there. But anyhow, all languages are directly same, right? Except syntax. Start now. This program, what will be the time complexity? This is the 9th problem. 8 problems in the last class we done. If anyone is not visited, if anyone is not done in the last class, I request you, please go through that first. If you are not done last class, I request everyone, please go through the last class. Already there, yesterday, this time I taken. 8 problems I done. Today is the 9th problem. Start now. So I value 1 started. See this one. I value 1, okay. I less than or equal to n, that is also okay. Right? I is equal to I plus 20. So if you observe clearly, every time you are incrementing by 20. So you may be, some people may be thinking that one loop is there n time. It is not like that. But inside loop, what you are doing, that also matters. Some people are thinking that so loop is there n time. No, some loops are log n. Some loops will take only log n. Some loops will take n square. So by seeing loop, don't say n. What is happening inside loop, check. So can you see this one? So if you observe clearly, inside this loop only one statement is there, that is also okay. So first remember, time complexity means loops only. So don't worry about other people. Small statement, don't bother. Time complexity means loop only. Okay, loop is there? Yeah. Now we will see the time complexity. Everyone observe. Time complexity means loop only. Observe now. So this loop is going on. This loop contains one statement, two statement, doesn't matter. So loop is there. So this loop is repeating how many times? Let's check. So if you observe clearly, every time you are incrementing by 20. Every time you are incrementing 20, not plus 1. You are incrementing 20. So it's something like this. Let us assume one simple question I want to ask you. Let us assume, right? Every time I assume that initially I have 0. Initially assume I have 0. Every time I incrementing by 20, then what the answer? 0 plus 0 becomes 20. 20 becomes 40. 40 becomes 60. 60 becomes 80. 80 becomes 100. So what I mean to say is, right? So see everyone now. 0, suppose assume n is 100. Suppose assume n is 100. So initially I value 1. So 1 less than or equal to 100, condition satisfied. So you will go inside. Observe this model. 8 problems item, they are small basics. It is a 9th problem. From now onwards, some logics will start. See what I am doing. I is equal to 1. Okay. 1 less than or equal to 100, that is true. So you will go inside. Then, right, I value becomes plus 20. So it became 21. 21 less than or equal to 100, that is also satisfied. Next one, if you go inside, 21 plus 20, it's going to be 41. 41 less than or equal to 100, that is also satisfied. Observe, don't be panic. Whatever I'm saying, listen carefully. Little doubt also there, comment section, you can comment. Next one, 41 plus 20, it is going to be 61, less than or equal to 100. Next one, 61 plus 20, which is going to be 81, which is less than or equal to 100. You are incrementing every time 20. See, right, there is a one person always plus 1, plus 1, plus 1, plus 1. He will do more number of time. But this person is always plus 20, plus 20. So let's see what happened. So next one, if you observe clearly, 81 plus 20, which is going to be 101, less than or equal to 100. So this is failed. This is failed. So if you observe clearly, you are able to go inside loop. How many times? 5 times only. You are able to go inside loop only 5 times. So n value 100, every time 20 incrementing only 5 times. So what is the reason? Remember, 100 by 20. 100 by 20. If you increment always plus 20, loop is right. Loop is 100 by 20 times, which is nothing but n by 20. This loop is going on n by 20 times. N by 20 times. I think everyone know n by 20 can be written as 1 by 20 into n. N by 20 can be written as 1 by 20 into n, but everyone know 1 by 20 is a constant. So this can be written as big O of n, omega of n, theta of n. So the time complexity of this program is big O of n or omega of n, theta of n, right? So actual answer is n by 20. The actual answer is n by 20. If anyone asks what the time complexity of this program, you can simply say n by 20. If they say, can you say little more better way? N by 20 can be written as 1 by 20 into n. So 1 by 20 is a constant. So n is there. So big O of n, theta of n, omega of n. What is the difference between these three symbols? In further classes, we will see. In further classes, I will explain what is big O, what is the omega, what is the theta, what is the difference, right? I will say afterwards. As of now, assume all three are same. So the time complexity of this, remember, time complexity means loop only. If no loop is there, time complexity is a big O of 1. If loop is there, next question, that loop is how many times? I think this loop is if at all n value 100, this loop is n by 20 times. If n value is 500 by 20 times. If n value is n only, n by 20 times. So time complexity of this program n by 20, which is nothing but big O of n, omega of n, theta of n. So I give an explanation also, you can see here. Here I is equal to I plus 1 will repeat. I is equal to, since 1, I is equal to I plus 20. I plus 20, not I plus 1. I is equal to I plus 20. I is equal to I plus 20 will repeat n by 20 times. First 1, next 21, next 41, next 61, and so on n. And so on n. So here the time complexity is n by 20 actually. This can be written as 1 by 20 into n, which is nothing but order of n. So problem number 9, I feel everyone got. Little doubt also there. Please let me know. You please raise the hand. I am there to help you. You just raise the hand. I am there to help you. Ready, sir? I didn't get this. Right? The purpose of this one is to clarify your doubts only. I came here. You have doubt. I came for clarifying your doubt, but you are not asking. Then why you came? Then why I came? Right? I'm taking class to help you. You came here to class. You came to the class, right, to learn. You have doubt. You are not asking. Because of you are not asking, I am not explaining. So definitely it is a serious issue if you don't ask. As a student, it is your responsibility to raise the doubt. As a teacher, I'm waiting for that incident when you ask doubt. If you ask doubt, I will help you. Question number 9, answer is actually n by 20, which is nothing but big O of n. Right? Try to understand. So question number 10 is over. If you don't have any doubt, please comment in the comment section, no doubt. If you don't have any doubt, comment in the comment section, I don't have any doubt. Yeah, this loop is running n by 20 times, which is nothing but big O of n, theta of n, omega of n, something like that. Question number 9 is over. Can you go to question number 10? Can you start now? Similar problem. See the similar problem, right? I always, time complexity means loop only. Time complexity means loop only. If you observe clearly this loop, always you are incrementing by 5. So it's going to be n by 5, which is nothing but a big O of n, omega of n, theta of n. So like that. Big O, omega, theta, any symbol you can use. So same thing. So the actual time complexity of this program is n by 5, which can be written as theta of n. I think problem number 10 also we done. Let's go to problem number 11. Can you go there? Can you go there? Problem number 11. Can you go there? Start. So I think if you observe clearly, listen everyone, very interesting, very interesting. You are decrementing. Decrementing doesn't matter. Loop is how many times, that matters. Decrementing doesn't matter. Loop is how many times. But when you say decrementing, remember, you started with a big number. If you start with a small number, if you decrement, right, then that loop never over. You start bigger, then you have to decrement. So that decrement, at some point of time condition will be failed. Already bigger, you have to decrement so that condition will be failed. Right? Now let's see this one. Let us assume n value 100. Next one is n value becomes 99. Next one 98 and so on. Continue. So it is a 2. Continue. It is a 2. After 2 it became 1. I value became 1. Now 1 is greater than or equal to 1. Condition pass. Next 0. Right? 0 is greater than or equal to 1. Fail. So you passed until here. So loop is I think everyone know. Always you are decrementing 1. Remember, always incrementing 1 or always decrementing 1. Both are n by 1 time. Incrementing always plus 1. If you start small, increment always plus 1. If you start big, decrementing always plus 1. They both will give n by 1 time. Start bigger, then you have to decrement. But how you are decrementing? Always by 1. So n by 1, time complexity of this program n by 1 means n time. So always you are decrementing by 1. So time complexity is n by 1. N by 1 can be written as big O of n. N by 1 can be written as big O of, right? Big O of n. Right? Remember everyone. Start bigger, then you have to do subtraction inside loop. Start smaller, then you have to do addition in the loop. But whether you do n minus 1, whether you do n, right? See, whether you do I plus 1, whether you do I minus 1, both will be time complexity n by 1. See, addition or subtraction, both are same. The only difference is that addition initialization should be from small number. Subtraction initialization will be some big number. That is the only difference. Whether you do minus 1, whether you do plus 1, both will take time complexity n by 1. If at all subtraction, you are subtracting, means you are decrementing, starting with big number. Then you are decrementing, some point of time it will stop. Right, like that. So question number 11 answer is n. What is the question number 12? Similar. Can you try the question number 12? Question number 12. Can you try this? Question number 12. Can you try this? Don't worry about this. Question number 12. Please understand. Try to catch everyone. Everyone try to catch this. Try to catch everyone this problem. Question number 12. You may see some interesting thing. See this one? Starting from big number, okay? You are starting from big number means you have to do subtraction. You have to decrement. Not subtraction. You have to decrement. Let's see how you are decrementing. First you are decrementing 5. I minus 5 you are doing. First you are decrementing 5. Next you are decrementing for the existing value. You are doing 1 more minus 7. For the existing value, 1 more minus 50 you are doing. Total, I think minus 5, minus 7, minus 12, minus 12, minus 50, minus 62. So overall, the story is going to be, always you are decrementing by I is equal to I minus 62. Always you are decrementing by 62. See, start from big number, you have to subtract. Subtracting, okay. Subtracting by how much? Always you are decrementing 62. This is nothing but time complexity n by 62. Addition, subtraction, both are same. Addition, start with small, then keep on add. Subtraction, start from big, then keep on subtract. But both, if you do I plus 62, n by 62, I minus 62, n by 62. So time complexity is going to be big O of n. Big O of n, omega of n, theta of n, something like that. In the last class, I done 8 problems. Today, I am going to cover 10 or 15 problems. 10 or 15 problems I am going to cover. So make sure if you understand yesterday's class and today's class, you are most probably okay with the time complexity finding. Small doubt also there, you can ask me. In the comment section, please comment. Little doubt also there, comment in the comment section. Little doubt also there, comment in the comment section. Right? Perfect. Question number 12, we are already done. Right? Question number 12, already we done. Time complexity, big O of n. Go to the, I think, total explanation also given. See, total explanation, total became 62. If n is right, n is isn't that 124, 124 minus 62, 62 minus 62. So 0, I think you done the 2 times. Just you done only 2 times. Right? First you tried this. First you tried this one. Right? Initially, I think, right, 62 less than or equal to 124. Right? One time you done. Next one, if you observe, it became 124. 124 less than or equal to 124. Lastly, I think it became, right? It became 124 plus 64. I think it's going to be 188 maybe. Right? Sorry, 186. Less than or equal to 124 fail. So stop. So 2 times you done, which is going to be n by 62. So same answer. So time complexity is actually n by 62, which is nothing but a big O of n. Okay, question number 12 also completed. Can you go to question number 13? See the question number 13. Everyone understand? Everyone try to understand the question number 32. Sorry, question number 13. Everyone try to understand question number 13. See the answer. Starting from big. Understand everyone? If you start from big number, you have to inside decrement. See how he is decrementing. First he is doing I minus 7. See the answer. First he is doing I minus 7. Right? Already I minus 7 you done. To that he is doing plus 9. Whatever you have, plus 9. Now whatever you have, again minus 50. Whatever you have, plus 60. So first you done the minus 7. Further you add the plus 9. Further you done the minus 50. Further you done the plus 60. Can you see overall how much? What is the overall value? Check. Minus 7 plus 9 minus 50 plus 60. Minus 50 plus 60, 10. 10 plus 9, 19. 19 minus 7. 19 minus 7, which is going to be 12. So I plus 12. Overall became I plus 12. So I think this overall value became I is equal to I plus 12. This overall became I is equal to I plus 12. But understand one interesting thing. Everyone try to understand. Very, very important question here. This is going to be very, very important problem. Question number 13 is going to be very, very important problem. See, already you started with big number. But overall, if you observe, every round you are incrementing 12. Remember, time complexity not related to any programming language. Time complexity related to logic. It does not belongs to any programming language. This loop is how many times? Already I is big number. Every time you are adding plus 12. Suppose assume it is 1 lakh. Suppose assume, maybe 1000. Assume that it is 1000. Already n is 1000. Already I is 1000. After every round, 12 is incremented. See, 1000 is greater than 1. 1000 is greater than or equal to 1. Yes. 1012 is greater than or equal to 1. Yes. 1024 is greater than or equal to 1. So I think this loop never over. It will go to infinite loop. Remember everyone. This algorithm never stop. Remember, a code where it never stop. That means it is not an algorithm. Algorithm means it should stop. So this algorithm taking infinite time, which is nothing but indirect way of saying it is not an algorithm. It is not algorithm. It is not algorithm. So we cannot find time complexity. It is not algorithm because it is not stopping. Algorithm first property, it should stop because it is not stopping. It is not stopping because it is not stopping. Algorithm means it should stop. Algorithm means it should stop. It is not stopping. It is not stopping. Please try to understand. It is not an algorithm because it is not stopping. It is not stopping. Right? Careful. It is not an algorithm because it is not stopping. So we cannot find time complexity. So we cannot find time complexity. So we cannot find time complexity. It is not algorithm because it is not stopping. It is not stopping. So we cannot find time complexity, which is nothing but, if you want to say little more better way, which is nothing but infinite time complexity. The time complexity of this program is infinite, which is nothing but undefined. Why it is not algorithm? Because it is not stopping. It is a very, very good question. Question number 13 is very, very important. If I don't cover somewhere, you may find out some difficulty. Somewhere you may say that, sir, why it is infinite, sir? Already you started with a big number. You are always keep on incrementing. Already big number. 1000 greater than or equal to 1. Assume n is 1000. 1000 greater than or equal to 1? Yes. Next round. 1012 greater than or equal to 1? Yes. 1024 greater than or equal to 1? Yes. 1036 greater than or equal to 1? Continue. Infinite time. So the time complexity of this program is undefined. Undefined means infinite. Time complexity of this program is undefined. Undefined means infinite. Why? It is not algorithm because it is not stopping. So we cannot find out time complexity. Understand, these all three lines are same. These all 3 lines or 4 lines are same. Time complexity of this program undefined. Time complexity of this program undefined. Time complexity of this program infinite. Time complexity of this program, we cannot find time complexity because it is not stopping. These all meanings are same. Some people will say time complexity infinite. Some people will say time complexity undefined. Some people will say time complexity we cannot calculate. Some people will say it is not an algorithm at all because it is not stopping. All are correct. For the question number 13, answer is all undefined, infinite. We cannot find out time complexity because it is not an algorithm. All are same meaning. Question number 13 also we done. Question number 13 also we done. Can you go to question number 14? Can you go to question number 14? See the question number 14? See the question number 14. I is equal to 1. Okay, see this one. You started from small number. You started from small number. I think most probably inside loop. Most probably inside loop. You are increasing. Increasing. That may be addition, but you are increasing. Let's check. So first you done I plus 7. Okay. First you done I plus 7. For that plus 9 you done. For that plus 25 you done. Yeah. Overall check. 7 plus 9, which is going to be 16. 16 plus 5, I think 36, 41. I think this total is 41. This total became 41. Which became, the meaning of this line is I is equal to I plus 41. So this total became indirectly I is equal to I plus 41. So I think every time you are incrementing by 41, remember already you started with small. You are always incrementing by 41, right? 41, 41, 41 increasing. At some point of time condition true, further it will fail. So answer is going to be n by 41. Time complexity of this program n by 41. So which is nothing but order of n. Which is nothing but order of n. Fine. 14 also we done. Almost everyone is comfortable. Almost everyone. Anyone having any doubt, please comment in the comment section. Anyone having any doubt, please comment in the comment section. Can you go to the question number 15? Can you go to question number 15? 14 done. Go to the 15. Starting with small. See this one. First, you done the increment 10. Okay. Just give 1 minute. Just give 1 minute. Right, perfect. Question number 15, see the question number 15. First you are incrementing 10. Okay. Afterwards you are incrementing plus 20 also. Yes. Afterwards you are incrementing plus 30 also. Yes. Overall is 60 incremented. Yes. So answer is going to be always you are incrementing 60, n by 60. So time complexity big O of n. Right, I think all logics, remember you are learning all logics now. Now you are learning all logics. Comparing yesterday, today you are learning some more logics. Yesterday some logics, today some more logics. Question number 16 also, 15 also we done. Can you see the question number 16? Can you see the question number 16? I is equal to 1. Right? Now listen, one more new logic. New logic is started. Right? New logic. I think everyone know, everyone comfortable with the addition and subtraction. Do you have any doubt? Addition, subtraction done. Some other model is starting now. Addition, subtraction is done. Some other model is starting now. Everyone observe. Some other model is starting. Right? I think until now addition, subtraction, same. Addition, start with small number, keep on add. Subtraction, start from big number, keep on subtract. Now new model is starting. It's a one more variation. New model is starting. One more variation. Can you see this? New model is coming. One more variation. Everyone observe. One more variation is going on. See this? Always you are doing a double. It is not adding plus 5. It is not adding plus 20. It is a double. What is the meaning of double? If n value 1 lakh, double means in the next round 2 lakh. N value 1 lakh. In the next round, right? In the immediate next round, it will become 2 lakh. N value 2 lakh in the next round, double into double, 4 lakh. 4 lakh, see, 2 lakh become 4 lakh in one round only. 4 lakh become 8 lakh in one round only. 8 lakh become 16 lakh in one round only. So remember, it look like very small, but it will affect a lot. So see this one. Initially I value 1. Next it became double, 1 into 2, 2. Next time it became double, 2 into 2, 2 square. Next time 2 square into 2, 2 cube. Next time 2 cube into 2, 2 power 4. Continue. Let us assume I continued 4 times 2 power 4, k times 2 power k. Assume I continued k time, it became 2 power k. Increasing, it became 2 power k after k time. Assume this became n. So termination condition. After doing k time, right? Then both became equal. So what is the k? So I done k time, then both became equal. After doing k time, it became both are equal. K times I done. If I do 1 time, 2 power 1. If I do 2 time, 2 square. If I do 3 time, 2 cube. If I do 4 time, 2 power 4. If I do k time, 2 power k. After doing k time, 2 power k, which is become n. So in the next round, it will fail. So k times you done, then this is the story. What is the k value? So apply log n base to both the side. Log 2 power k base 2. Apply log base to both the side. It became log n base 2. So it became k into log 2 base 2, which is 1, which is equal to log n base 2. So k became log n base 2. Remember, this loop is repeating log n base 2 time. This loop is repeating log n, k times you repeated. This loop is repeating log n base 2 time. So time complexity became big O of log n. Right? This loop is repeating log n base 2 time. So time complexity became big O of log n base 2. right? See the total story. See the total story. See the total story. So first time 1, right? So initially 1, next into 2, next into 2, next into 2, next into 2, and so on, and so on. K times I done. It is the n which is 2 power k. After doing k time, it became 2 power k. After doing k time, it became 2 power k. After k iterations, the value of I will be 2 power k. Yes, exactly. Then this is the relation which happened. Apply log base 2 both the side. It became k became log n base 2. So you repeated k time, which is nothing but log n base 2 time. Afterward, this loop is terminated. So time complexity big O of log n. This is the new variation. Please be careful. It is a new variation. Please be careful. So the time complexity of problem number 16. Problem number 16 time complexity became log n base 2. Problem number 16 time complexity became log n base 2. Let me know anyone having any objection. You may be having doubt. To me, they are very simple because many times I done. To me, they are very simple because I done many times. I done many times. To me, they are very simple. So time complexity of question number 16 log n base 2. Time complexity of question number 16 log n base 2. Little doubt also there. Please go through it. I will give the notes also. If anyone want notes, you can ping me. You can ping me. I will give the notes also. Right? Fine. Go to the question number 17. Go to the question number 17. Everyone try to understand. See the question number 17. And I want to say one important thing to all of you. Right? I want to say one important thing to all of you. DSA course. Right? DSA course. Right? The DSA course is started now. DSA course is started now. DSA course is started now. So within 3 months, you are able to complete the total DSA. Within 2 months, sorry, within 3 months, total DSA will be completed. 3 more months you will practice. Then everything is all right. Within 3 months, you will become DSA expert. 3 more months, do practice. You are going to be extraordinary in the DSA course. You are going to be extraordinary in the DSA course. Right? So 80% discount going on, you can utilize. 80% discount going on, you can utilize it. So go to ExamPrepTool.com, DSA course you can take with system design. You are going to finish all the things. Right? I is equal to 1, while I less than or equal to n, I is equal to 3 into I. I is equal to 3 into I. So I think same problem. Can you see this one? Same problem. If you observe clearly, same thing one more time I am doing, please see. Initially 1. 1 into 3, 3. You are doing a triple every time. Into 3, so 3 square. Initially 1, okay. After 1 time 3 power 1, 2 time 3 square, 3 time 3 cube, 4 time 3 power 4. If you do k time, k time 3 power k. If you do k time 3 power k, which is equal to n. So I think if you I want k times I done, what is the k value? K times I done, what is the k value? K times I done, what is the k value? So I think if you see the k, if you want something which is there in the power, if you want, right? So you have to apply log so that it will fall down. So it will become k log 3 base 3. Apply log 3 base 3. Right? Apply log base 3 both the side. It became k log 3 base 3. It became log n base 3. So finally k became log n base 3. K became log n base 3. Simple. Every time into 2 log n base 2. Every time into 3 log n base 3 series. Every time into 2 multiplication into 2 log n base 2. Into 3 log n base 3. Into 10 log n base 10. Into 20 log n base 20. Because series will come like that. So if at all into 2, powers of 2 will come. Into 3, powers of 3 will come. 3 power 1, 3 square, 3 cube, and so on. So finally 3 power k is equal to n. Finally k became log n base 3. Right? Time complexity is big O of log n base 3. I hope everyone is comfortable. Everyone is comfortable. Right. Let's move to problem number 18. Let's move to problem number 18. Can you see the problem number 18? Everyone observe. Can you see the problem number 18? First you done 2 into I. You made double. Whatever you have, into 3 you done. This is the new I. I is equal to 2 into I. It is a new I. For the new I, you done into 3. Into 3 you done. It became overall, if you observe, right? It became I is equal to 6 into I you done overall. It became I into 6 into I. It became I into 6 into I. Right? Then I think this is nothing but this. Always you are multiplying by 6. Always you are multiplying by 2 log n base 2. Always you are multiplying by 3 log n base 3. Always you are multiplying by 6. It became log n base 6. It became log n base 6. Big O of. It became log n base 6. Big O of. Always into 2 log n base 2. Always into 3 log n base 3. Always into 6 log n base 6. So same. I think if you observe clearly, you will get the powers of 6. Right? 6 you will get 6 power 1. Right? Next one 6 square. Next one 6 cube. Finally 6 power k. Finally 6 power k is equal to n. K became log n base 6. Excellent. Till now, excellent. 18 problems we done. Till now, we done the 18 problem. The purpose of within 3 months, you will become expert in DSA. Don't cry in the social media. Every YouTube person will say whatever they want. Every YouTube person will make the DSA very complex. I guided from the 15 years onwards, lakhs of people. I will guide you also. If you want to be expert in the DSA, within 3 months, I will make you DSA expert. 3 months only. Just give 3 months. You will become a DSA expert. Whatever I will say, just do that. Whatever I will say, just do that. 3 months you will become expert. 3 more months you do practice. More than enough. Question number 18 also done. Go to the question number 19. Question number 18 we done. Go to the question number 19. Everyone observe. Everyone observe what is the question number 19. See the question number 19. Remember everyone. Everyone observe. Very interesting. Very interesting. See this. Very interesting. Start from small. See this one. Start from small. 1. Everyone observe. 1 into 2. Again into 2. 2 square. Again into 2. 2 power 3. Again into 2. So 2 power 4. And so on. Assume. And so on. 2 power k. K times and 2 power k. Everyone know this program. If at all always into 2. Log n base 2. Time complexity becomes log n base 2. Everyone know this. Time complexity became log n base 2. Everyone know this. Always you are doing into 2. Log n base 2. That is okay. So if you start from upper, where small number. If you start from small number, always into 2. Log n base 2. If you start from big number, always divide 2. If you divide always 2. 2 power k by 2. 2 power k minus 1. Again by 2, 2 power k minus 2, and so on, 2 power 1, and so on, right? 2 power 0. So this is also log n base 2. Remember, you always will see whether you do into 2, whether you make a double, whether you make a half, both are same. Addition, reverse is subtraction. Multiplication, reverse is division. Into 2, reverse is divide 2. Start from small number, always double, log n base 2. Start from big number. See, he started n. 2 power k means n. He started from n. Always you make half. Always you make half. That is also same story. The only thing is the reverse order. If you start from small number, always double. So 2 power 1, 2 square, and so on, 2 power k. If at all, if you start from big number, always half. By 2, by 2, by 2, by 2, by 2, it will be like that. It will be like this. So n is equal to 2 power k. K will become log n base 2. Same answer. Same answer. Some people are asking, sir, can you explain? I will explain. See, first n. See the proof. Same story. Same story. First n. Next became, right? Next became whatever you have. Whatever you have. By 2 you do. Whatever you have by 2. Next n by 2. Next one. Whatever you have by 2 you do. By 2 means n by 2 square. Whatever you have again by 2 you do. N by 2 square by 2, n by 2 cube. N by 2 cube. Continue. If you do k time, it became n by 2 power k. Right? And some people are asking, sir, you are decrementing. Lastly, it became 1. Termination condition. See, I think 1, right? 1 greater than 1 condition is fail. So until 1, continue. until 1 continues. So continue. Finally, n is equal to 2 power k. So log n base 2 is equal to k. Same story. Log n base 2 is equal to k. What I mean to say is whether you do into 2 or whether you do divide 2, both are same. If you do into 2, it is increasing. Start from small, always double, 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 double. That is also log n. Start from big n, always do half, 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 half. That is also log n base 2. This is the proof. So in the case of the double, power is incrementing upper. See, power incrementing upper. In the case of double or triple, power incrementing upper. In the case of divide, power incrementing niche. See, 2 power 1, niche see, n by 2 power 1, n by 2 square, n by 2 cube. This is the only difference. At the end of the day, both are log n base 2. Right? N by 2 power k is equal to 1. N is equal to 2 power k. K becomes log n base 2. Time complexity becomes log n. So problem number 19 also you done. Problem number 19 also you done. Problem number 19 also you done. Can you go to problem number 20? Can you go to problem number 20? Almost similar. We'll do this also. Let me remove unnecessary. Right. Now see the answer. I think same story. Same story. See this one. Same story. Everyone listen. You are doing by 2. Okay. Whatever you have by 2, again that one you are doing by 3. So which became I by 6. Which became I by 6. I is equal to I by 6. Right? Initially you done by 2. Okay. To on that again you are doing by 3, which finally became I is equal to I by 6, always by 6, which will become log n base 6. Same story, log n base 6. Question number 20, answer is log n base 6. Question number 20, answer is log n base 6. Right? I think time complexity of this one is, see, if you want you can check. First n, next n by 6, next n by 6 square, next n by 6 cube, and so on. Finally, n by 6 power k is equal to 1. Finally, n is equal to 6 power k. So finally, k becomes log n base 2, log n base 6. Therefore, time complexity because of log n base 6. 20 also we done. Let's go to 20. Let's go to 21. Everyone understand? 21. I think, yeah, this may be the last problem. Observe here. Observe here. 21. Question number 21. Can you see one time? Can you see one time? First two, I by 5. Remember, you started with a big number. You started with a big number means inside should decrease. What is happening? We'll check. You started with a very big number. Inside you should decrease. Then only termination condition you will see. See what is happening. First you done by 5. Okay. First you done by 5. Okay. Whatever you have, you done by 7 also. Right? Which is nothing but I by 35. 5 7 35. Check properly. Next one. Whatever you have, you done again by 2. Which became I by 70. Now next one. Whatever you have, again you done by 2. Which became I by 140. I by 140. Now understand. Whatever you have, into 4 you done. Into 4 you done. Please check properly. Into 4. Then what is the answer? Right? I think 4 ones, 4 twos. Sorry, 4 threes, 12. Now 4 fives. I think 35. 35. This became I by 35. Overall I by 35. So what I mean to say is already you started with a big number. Right? Overall, every time you are dividing by 35. Always dividing by 35. Answer is, right, log n base 35. Log n base 35. Log n base 35. Careful. Always you are dividing by 35. Log n base 35. So see this one. After k iterations, I value, right, it will become n by 35 power k is equal to 1. Finally, n is equal to 30 power k. Finally, k becomes log n base 35. Time complexity becomes log n base 35. See, so many problems. 21 problems I done. They are very, very easy. Very, very easy. Very, very easy. Yesterday's class you see, today's class also you will see. Almost you got what is the meaning of time complexity. Yesterday's class you see, today's class also you will see. What is the time complexity? You will get to know very easily. Very easily you will get to know this. Very easily you will get to know this. Right? So DSA course, so this is the course. If you go to the EPT placement course, if you see DSA system design course, this is for right placement purpose. Right? In the GATE CSC people can go to the 1 year course. 2027 GATE examination, you can go on. 2027, 26, I think time is very less. Right? There is no use for 26 people. 27 people can go here. 1 year course. Right? You can go for 2 year course also. 2 year course also. 2028 people also can go ahead. Right? Next one. GATE DA also. GATE DA course also there. GATE DA 2 years course also. And GATE CSC plus placement also combined. Right? Fine. Perfect. Perfect. Right? In tomorrow's class, we will see. Right? Tomorrow's class also, if you attend, you will get the total time complexity clearly. Tomorrow's class also, if you attend, total time complexity you will get clearly. Small doubt also there. In the comment section, you can write. Or you can WhatsApp us. You can WhatsApp us. We are going to help you. You can WhatsApp us. We are going to help you. Right? You can WhatsApp us. We are going to help you. Small doubt also there. You can WhatsApp us. We are going to help you. Yesterday's class, today's class, you check. You will get the full clarity about time complexity. Little doubt also there. In the comment section, you can comment. In the comment section, you can comment. Right? Perfect. I'm thinking everyone is perfect here. Thank you. Thank you. See you in the tomorrow's class. See you in the tomorrow's class. Someone is saying that in which language you are taking. It is a combination of all, right? C and Python, combination of both. C and Python, right? Combination of both. Both are there. Yeah, fine. I think 21 problems item in tomorrow's class, right? I will cover approximately one more 15 problem. 10 to 15 problems I will cover in tomorrow's class. In tomorrow's class, I will cover 10 to 15 problems. Overall, you will get the time complexity clearly. Right? Fine. See you in the tomorrow's class. Thanks, everyone. Thank you so much.